people started buying into it, and it was kind of taking off. So we started developing on it more. And then at the time, he and our CEO, John Amaral, were working for CloudLock, which is a security company that was bought by Cisco. And they said, this seems like, a pretty big problem space, and maybe we should turn this into a company. So took a few years to get that together, but then they launched Slim.ai, kind of came out of stealth in 2020. And the mission is to help developers build secure containers faster. So, there are a lot of different approaches to kind of slimming containers, but what we've seen is that, some of them can be hard for developers to kind of grok and understand, and it requires a lot of expertise, and it still requires sort of too much manual effort to sort of take your containers, make them production ready, and then work with them all of the time. And what started to really resonate with people as we started launching the platform and getting more people using Docker Slim and all that, as we started launching, was to was the security messaging, right? We're removing a lot of unused vulnerabilities that are in these containers. And when we do that, we're reducing the attack surface of the containers. So that was kind of where the company started and where we are now. And then we've launched a SaaS platform, which we're going to kind of walk through. We have a Docker extension that we just launched back at DockerCon, which is pretty exciting. So that helps for local development. That's really awesome. And then we've built tons of connectors up to all the major cloud platforms, including ECR, that really make it a lot easier to kind of move things through CI/CD and connect up to your infrastructure, work with your images. So that's all the stuff that we want to show today. And that's kind of where we are as a company. So, yeah.
Great. And I know that a lot of folks try to create slim images, partly because there's this belief that slimmer images have a smaller attack surface. And I think that's largely true. But from reading about Slim.ai, there may be this false sense of security with images, what we think of as slim images like Alpine and Distroless that contain vulnerabilities. And so as part of today's session, are you going to talk about how Slim.ai can help not only create minimal images, but also more secure images?
Yeah, that's absolutely something we can touch on today. And we can, dig into the Distroless example if we get some time to touch on that one. Yeah, totally.
Yeah, and I think the proliferation of vulnerability scanning tools has really brought this to the fore, right? Sneak and Gripe and Trivy, have all really made developers aware of just kind of how many vulnerabilities might be in an image. And we'll show you sort of an image built on Python latest, which, most people would know not to kind of do that and send that to production. That's a good development image, but it's kind of astounding how much can be there. But there's other elements of attack surface like shells, package managers, files with special permission, these things that your everyday developer is not going to know to go in and take out, but they can be exploited once things are in Kubernetes and stuff like that. So those are other things that Slim can kind of help with. Alpine and Distroless have sort of just a different take, which is to start with something really small, then add only what you need to it. But I think with us, it's developers are going to want certain tools, curl and text editor, something like that in their containers that they're working with in development. And they want an automated process to remove those as they go down into production. And that's kind of our take on the workflow. So,
yeah.
So I had a question there with regards to that, because I was talking to Jeremy about this exact thing before we started. So, as we are troubleshooting and developing, we need all our tools, but when this thing goes to production, I would like to have it as, slim as possible, no pun intended. And, again, like Jeremy said, also, reducing some attack surfaces maybe, but, that means also the trade-off there is that if I take out the plumbing, then nobody can get into it, if they wanted to troubleshoot it as well. Now, with Kubernetes, now you can use ephemeral containers, and that makes it easier there. From a non-Kubernetes world, though, it might make it harder to troubleshoot. But do you see that workflow as, once they get to a point where we're ready to go to production, they're going to squash everything into one layer and put it out there? Is that what you're looking at?
Yeah, Yeah, so one of the use cases is you want those large, well-instrumented containers to be working on, for your iterative development processes. So you want a comfortable distribution that's easy to work with, and you want to load it up with your dev, test, QA tooling and your infrastructure tooling. Not everybody does this, but there are some people out there that do. But once you're sort of validating those things internally, you want something in your CI/CD pipeline that takes that and turns it into something that's production ready. So that's definitely a use case for Slim.ai or Docker Slim, is take those large, well-instrumented containers and turn them into something palatable for shipping into production. And there's a number of ways of doing that. And, you can always start with container best practices as well. And if we get time, we can show how, like the Docker Slim origin story of take containers made by developers that maybe are not yet experts in composing containers, and take those sort of proof of concept containers and turn them into something production ready. So we have a lot of different places we can go with the examples we're going to explore today. And it's really going to be guided by the questions that we get and the prompts that we get as to, the different routes that we can take. But we can totally dig into all of that.
Yeah, and Jamie, I think you hit on one thing, which is like what a lot of people who encounter Docker Slim for the first time kind of look at it and they're like, it might be too much, because like I don't know what it's doing, and it has a lot of flags to instrument it, and it's you got to kind of figure it out. A lot of this Slim SaaS tooling has been meant to augment that and help that sort of confidence that you're talking about, right? Where like, okay, I've created this Slim image. Is it actually the same as this one that I was working with in production? Because that reproducibility is like the whole point of containers, right? So like, let's make sure that that's safe. So we have this diff tool that helps you look at sort of the production ready image versus not, and we'll show that. I think also just keeping the record of both, you have sort of the original container and then the Slim container. And when those are sort of under management and you have good tagging systems, you can kind of know like, okay, this was removed from this container, and then this is what the original one looks like. And our tools do work on the Slim containers, things like the visibility tools that will show you, they work on the Slim containers. You can see inside those containers. You might not be able to curl something into them like you would on a command line. But we're trying to tackle that problem of like, okay, what is this Slim container and how does it compare to that one that I had been working on in development? So,
and those analysis, I mean, we should probably start jumping into some of the practical examples, but those analysis tools are really useful because it also enables you to do some due diligence on the quality of the containers that you want to use in your production environment. So if you're, building on top of a base image or an image from a project or a vendor, you can actually go and look at those and see, what's in them, how are they set up, configured, do they adhere to best practice, do they adhere to any policies that you might have. So we can jump into some of that. I've shared my screen. If you want to activate that,
let me pull it in there.
So I think, Pete, the first thing that you were talking about was where we started with the Slim platform. So we have this sort of concept of being almost like Google for container images. And we've got some curated apps here. I'm a fan of Ubuntu as a result of having worked at Canonical. I still do a lot of work on top of Ubuntu. And we can see here, this is the base image for Ubuntu, and this gives you a view of what you can see. So if we were to look at Jammy, for example, which is the latest LTS release, we can see that tagged here. And we can see an overview of this container. It will just take a minute to explore. We can see the different layers. We can explore the file system layout for each of the containers. We can see what the startup is. We have an overview section here, which gives you a whole bunch of facts and insights into this container image, including all of the shells that are present, all of the files with special permissions. So just at an overview, this gives you a cursory glance of sort of, the container that you're looking at. And you can use this to really poke around and find out, well, how was it even constructed? Obviously, a base image of a distro is a pretty simple from scratch, import tarball. So Pete, where should we go from here?
Well, so I think, looking at base images is great. It's a great way to start. You know, I usually start with like Python latest or something like that, but most people are going to be developing their own apps, right? So you have an app, I think, that you've been working on that's just a pretty simple Python Flask app as an example. So maybe, oh, you know what? First, let's look at connectors, because I think that's one thing that's
Okay.
important. We've actually put these applications into an ECR repository. We've been playing around a lot with ECR. So we have connectors to all the major platforms here, you know, including Docker Hub, you know, ECR, GCR, different ones. And so once you've authenticated, created an authenticated connection, you can pull in your own images from your own infrastructure. And if you go over here to connected registries, we have a few demos here. So Martin can kind of go through what the apps are that we've built.
Yeah, so we've got this here. We've got an imaginatively named app called app. The app is kind of irrelevant for the purposes of this demonstration, but it's actually a Python Flask app that implements an even simpler API with just 2 endpoints. And what we've done is we've built this app using 3 different sort of container composition mechanisms. One against the official Python base image. And as Pete said, we've deliberately used Python latest to be sort of naive new developers here. And we've ended up with a 355 megabyte container. And in fact, it's bigger than that, of course, because this is the compressed size. And then we have one built against the latest Ubuntu LTS. And we have another, which is a multi-stage Distroless build. You can see here they're different sizes. So which one of these do you want to look at first, Pete?
Why don't we look at the Python one first? And while that's loading up, I see Carlos is in chat, and he says, GUI looks neat. I've only used the open source through the CLI. So yeah, it's a good point. So a lot of the back end tooling here is like the people who know the Docker Slim X-ray or the Docker Slim profile capabilities. A lot of that's built into the SaaS here. So that's kind of like underlying. We've added some new things that are only in the SaaS version, but that's like, you know, there's you'll see a lot of corollaries between those two tools.
So yeah, just about everything we're going to show you today is sitting on top of Docker Slim, our open source project. So Docker Slim is an expert tool. It's very powerful. You can do a lot with it. And the Slim SaaS platform is building on top of that to give you a better developer and user experience to sort of turn those knobs and dials. So where were we? We were, here we go. So here is our app. We can see here it's composed of 13 layers. We could look at what was added and removed in each layer, and we can see what's in the container startup files. And in the same way, we can go and take a look at the overview here. We can see some things about it, the ports that are exposed. This is interesting. We'll come back to this later. We can see the duplicate file count and the wasted space. So in some cases, it's possible to slim containers by not removing any actual content, so to speak, from them at all, but just by sort of cleaning up mess. We've seen some significant gains with some very large containers where we can just clean up this stuff. And sometimes it can be as simple as like cached files in the build process. And again, we can see a selection of shells here, some files with special permissions and stuff like that. And certificate bundles is good to take a look at.
This is really nice. I mean, it reminds me a little of the open source utility Dive that allowed you to analyze, like reverse engineer a container image and look at the files on the file system. I like the way that this is designed, though, where it groups different things into categories. That's really nice.
And you can see here, look, these were the layers in which this directory was, you know, modified in some way as well. And you can hop directly to those layers to see what the changes were. I'm not going to explain how the whole UI works. You get it. You can dive quite deep with this. So
you might actually, you could even open up the application file and maybe show the sort of text version, but there are a lot of similarities to Dive in this tool. This is like a web-based version, but we do get that comparison a lot. Between this and Dive. So
so we can see the basic file properties, and we can even, you know, actually look at the content of the file. So I said the app was irrelevant and it was very simple, and as you can see, it is extremely simple. It's just it's just a couple of endpoints, but its function is not the headline feature. So
yeah, well, I think looking at vulnerabilities for this is a reminder. This one was built on the Python latest base
okay.
image, which is probably not the best thing to do. But
Okay.
here,
So
yeah,
go on,
go
Pete.
ahead. I was just going to say here we're using a couple of open source tools to scan the container for vulnerabilities. So Anchor's Gripe and Trivy. So, we're listing out all the vulnerabilities here. We have 373, which is kind of a pretty ridiculous amount. But again, we use sort of a naive approach to creating this. But this really allows developers to go through and kind of go through each of the vulnerabilities that they're going to see in their platform. And this will come in when we talk about optimization in just a minute. I know Carlos had a question about signing and SBOMs. I definitely want to talk about that, but maybe we'll talk about that after we talk about optimization and that workflow. So,
yeah. So I've just brought up one of the reports here is a critical vulnerability that exists in Python mailcap. That's a built-in module of the Python language. So that's actually a feature of Python itself. And this, is what you'd expect to find, the full, vulnerability report and all the details about it.
Mm-hmm.
And I suppose what I feel about this is I used to be a vulnerability analyst, and all those years ago I would have paid top dollar for a tool that did this, because back then we were doing this sort of thing by hand in spreadsheets and it was miserable. But I think there's a little bit of fatigue starting to set in with developers these days, in that they are seeing reports like this, and then it's like, well, what do I do now? So I think, Pete, should we optimize this image and see what we can do? Or
I think, why don't we go to the Jammy image, just because I think that's a little more of a real world example. Okay. So that one's built on top of that smaller base image, which is kind of similar. Like if people are just going to build something on Ubuntu, and that's a little bit of an easier image to kind of grok and understand, I think. So, we can do the same things, but it'll come into we'll kind of circle back on the different images that we have in a second with our diff tooling. And that sort of helps show what the black magic that's happening during the optimization process is, I think, a bit more.
Yeah.
So,
yeah, and I think this is a more sort of best case example. This container was constructed with container best practices and a thought about best security practices for containers. Although I did make a mistake when I built this container. I forgot to drop my build caches when I built this. So I actually built this on top of a several weeks old version of the Ubuntu base image. So I've actually, by the virtue of using layer caching to accelerate the build, I've actually managed to introduce vulnerabilities into this container. And it's a rookie mistake. And I actually have this in a talk I present about best container practices, not to fall into this trap. And I've done precisely that. But here we go. We've got the same thing. So we'll have a look at the vulnerabilities on this one. And we can see it's only 17. So far fewer vulnerabilities. It's the same app. We have taken more care in the way this container was composed. There are just 4 critical vulnerabilities, 9 high risk and 4 medium. Oh my goodness, they're going to do the vacuuming. I'm going to have to shut my door.
Yeah, I have a couple of questions in chat I can field while we're coming back to this, because I think we wanted to dive into one of those vulnerabilities in a second. But somebody asked comparison with the Docker desktop for images and to run a container. So we do have a Docker extension. So all of these tools are available, and we'll show the Docker extension. I don't think we need to show it now, Martin, but we'll try to show it at the end. All of these tools that we're going to run through are mostly available in our Docker extension, which you can find in the Docker extension marketplace on the Docker desktop that was just launched back in May. And that really helps for local development. So you can actually compare your images that are on your local machine to the images that you have in Docker Hub. And I think we have an example of that we'll show. So that's that one. And then Carlos is asking about, was using a very old version of Ubuntu and Node and was not able to upgrade to the latest versions as the staff service to address this. If I understand the question, it's that the Docker Slim version you were using wasn't available. Maybe I need a little more context on that question. But yeah, the SaaS is meant to be sort of a level playing field for everybody, where you don't have to worry as much about sort of your local configuration, or you don't need to know all the 128 configuration flags that are available in Docker Slim build. That's sort of the meaning of the optimization. So yeah.
Okay. So what should we do now then, Pete? Should we actually try and optimize
I think
this?
you were going to try to find that one.
Oh yeah, that's right.
The mail and show the
So
sort of search
yeah, we were
inside.
talking
Yeah.
about Python mail cap. So we know that this vulnerability is in this container. So let's go and see if we can actually find that. And we can use the tools here to actually go and do a search. So if I just search for mail cap, here it is. In fact, this is the pure Python module that's shipped as part of the Python language. And this here, if you're familiar with Python, this is the compiled bytecode. You can choose to add, remove, throw away or regenerate your bytecode in your container images. We've kept them compiled for startup performance reasons. But there it is. This is a vulnerable component in our application. And I suppose the question really is, knowing that you have a vulnerability is one part of the issue, but can you make them go away? So should we try and do that? So we're going to use the optimize feature here, and behind the scenes, this is going to be using Docker Slim. Now, what we're going to do here is when we slim this app, you can see we're going to be using the container that's published in ECR. And what we're going to do is we're going to publish the result back into our ECR registry. So this is going to create an optimized container image and then publish it back into that registry. So my app is indeed a server application. We've been given a hint here based on the content of the container image. And if we look here, I'm being asked, are there any other files or folders that I mandatorily want to include? Sometimes we've seen this with sort of web apps, for example. You may have static assets and the integration tests may not touch all of those static assets, and you may have things left out. So you can choose to pick places on the file system that you just want to be included all the time. As it happens, I don't need that for this application. And for this application, I do not have a Docker Compose file. As we've seen, it's a very simple app. It's a single service. But if you've got Docker Compose and you want to treat a whole bunch of services together as a logical whole, you can do that too.
Yep.
I'm not going to make any changes to my environment, but I could do if I wanted to. And again, this is just a simple way to expose a number of the knobs and buttons that exist within Docker Slim. And if I wanted to, I could edit this configuration and, add additional flags from the Docker Slim palette of options. But we're just going to move straight along to optimizing. And if I drop down the log here, you can see in the background, this is Docker Slim running, and this is it running its automated analysis and minification of the container. And if I scroll back up here, we're done. Yeah. So we can see that the container that we put in here was 132 megabytes. This is the uncompressed size of the container. And the minified container is now 26 megabytes. So we're getting just over a 5-time reduction there. So if we go back and analyze this container, given that it's now smaller.
Martin, just a quick question. Carlos is kind of asking the question that a lot of people ask, I think, which is, and I think you might need to go back to the actual Jammy Slim one because that link.
I've been dropped out of my group. That's what's happening.
Yeah. So a lot of people ask like, what's happening, right? And I think with the optimization kind of wizard there, you get a sense of sort of more or less what Docker Slim is doing, which is that it's actually running the container, your original container, and when it's doing that, it's doing a number of things, but some of them include sort of probing on different ports or probing for different API endpoints or routes in a web application that it might find. And when it does that, it's using a variety of Linux processes, Linux kernel processes to see what's actually firing in the container. It combines that with sort of static code analysis, which a lot of people are familiar with, to say, okay, like what is needed in this container in order for this application to run? And then I'm going to rebuild the container with only those things. So when Martin was showing that sort of like include list, that's a very common Docker Slim feature that people use to say like, well, include this folder or include this set of images, because they might not get caught in this HTTP probe process,
Yeah.
but I definitely want to keep them in the image. So there's always a little bit of tuning that goes in, and that wizard is meant to kind of like make that tuning so that automation process is, you know, as we were talking about before, like easier to trust, like, you know, more predictable, you know, that kind of thing. So,
And
Yeah.
Peter, you may get to this later, but are you using things like ptrace to look at the syscalls
Yeah.
issued from the application? If you are, is it also possible to generate like a seccomp profile
Yep.
for this and,
Yeah.
and attach it to the image,
Great.
or not the image, but like if you're
Yeah.
running the container
Great.
image with Kubernetes specifying, oh, okay, great.
Yeah, great question.
That's
So
awesome.
Docker Slim actually outputs an app armor and a seccomp profile by default. We're going to be bringing those into the Slim SaaS platform, so that'll be an artifact that you can actually, like, you know, keep and manage. And then yeah, so and we are using ptrace. We've done some experiments with eBPF, but I'll say they're not in the platform just yet. And I see Big Pod, who's one of our developer experience engineers, is in chat, and he actually just authored a blog post on our Slim.ai site that goes through sort of like what's going on with Docker Slim under the hood and goes into a lot more technical details. So if people want to check that out, that's a good read. So
And on
I'm sure you get asked this all the time. Oh, sorry. I'm sure you get asked this all the time, but what does the AI stand for in Slim.ai? Is it artificial intelligence, or is it something else?
It's a little aspirational. It's a little like tongue in cheek for us. So we say that it's application intelligence, is kind of our tongue in cheek way of saying it. But I do think that we are starting to look at different, I'll call it's more machine learning than artificial intelligence. But right, if we have the Slim container, right, and we're about to look at a diff of a container. So this is a good question, timing wise, right? So we've removed certain things from this original container, and now we have this sort of like slimmed profile container. Well, if we know that's a Python image, that's like a web application that uses Flask, you know, like we start learning over time, these are the types of things we tend to take out of those types of applications. And these are the things that we tend to keep in those applications. We can start feeding that back into the system. To be clear, we're not doing that right now, but I think that's sort of like something that we see in the long-term vision of the company. So
yeah, I don't think it'll be so long before we sort of own that AI for its traditional sort of
DC decided domain TLT. Not too far off. I like it as a growth person because it's easy to remember. So it's like Slim.ai, people know where to find you. You don't need to send people URLs, you know, all that kind of stuff. But
So I wanted to ask a question with respect to when we first time we went into one of the analysis and we were looking at the files. I thought I saw farther down something like set UID, set GID. And when we talk about container security, one of the things we talk about is defanging containers, right, and taking those bits out. And you know, do you expose that to at least show that that's
let's have a look. That's a great question. Let's look at that right now. So what we're looking at here is the analysis view of that Slim container that we just created. You'll see it's now a single layer container. That's one of the things that Docker Slim does, is it creates a single layer container from the assets from the original container that your application actually needs. And we can go and poke around in here and look at the file system, but let's get to your point. So here are these basic facts and the key insights. So you'll now see that it's been reduced in terms of the size and the number of duplicate files, but you'll notice now, look, there are no shells in this container. And the only files with special permissions is /temp. So it has removed all of those files that had sticky bits and what have you. So
Martin, are you going to do the are you going to do the diff of this in the original Jamie one? Yeah,
we've got this smaller container, and you know, back when we first started working on this, the question we always got is, what did you do? What did it just do to my container? So this is the purpose for this. So we're going to say compare. So we're going to look here, and we've got the Slim app, and we'll go for the jammy version, so the original what we call fat container, and we're going to compare that against the Slim container. And we could dive into some deep file system searching and digging around to go and see what's changed. You know, we can see here, for example, you were talking about defanging. Our app doesn't need the requirements file. We could well be leaking things in that requirements file we don't want in production, so that's gone away. But this is a bit verbose. It's very useful. So we've got this metadata diff here, and we can immediately see the size change. And here again, look, here's that. Here's the shells that were removed. Here are all of these set GID, set UID files that got removed. And you can see, you know, duplicate file size count has come down considerably. So this is sort of a good at a glance what changed. I think, did we want to look at the unified diff? I can't remember if we were going to.
I think we want to see the vuln diff, which, to be clear, is
the vulnerabilities.
Very beta feature. Our kind of design style here at Slim is that we just put things in tabs until we decide that they're important enough to put them in a better place in the UI, which is what we're working on right now. But this is that's kind of where this feature is right now. So
yeah. So this is the FAT container, which had, I think, was it 17 vulnerabilities? Here they are, and we can see in the minified container that there are no vulnerabilities. And we can, in fact, sort of verify this to some extent as well. So if I go back to the container itself, there we go. Get the Slim container. We'll go to the analyze and view. We know that that mail cap module was vulnerable and in the original. So let's just actually prove to ourselves that that has indeed gone. So if we do the same search, no results come back.
And then if you click on vulnerabilities here, you should get the same vulnerability report that you just got, right?
No, that at the moment doesn't do anything because we haven't moved that report to here.
Oh, okay, got it.
This vulnerability stuff is sort of early access at the moment. So if you want to come along and have a play with this, you know, by all means sign up and get in touch, and we can enroll you into the sort of design partners program so you can get at all of this.
So again, you mentioned scanners earlier. I mean, you mentioned Anchor's Gripe and Trivi. So do you have others on your radar? You know, do you foresee an opportunity where folks can pick and choose which ones they want, or all of them? Or?
Yeah, I mean, we're hoping to have as many of them as we can. I think we don't want to be a scanning company ourselves. We think there's a lot of really great scanners out there, but I think it's important to see everything in one place because a lot of them report different results, which is what we're encountering very often. So, you know, I think if people are using Sneak, you know, hopefully we'll be able to support them soon. We do a lot of work with them on the DevRel side and just love that company. We're talking to other container scanning companies as well, where the conversations are kind of, you know, less mature, but I could see us bringing them on the platform. So if you have your own license, you know, come with it. And if people have requests for scanners that they're using that they want to see on the platform, just let us know. Martin mentioned we have a Discord that people can drop into, and it's a good place to get product updates or, you know, give us feedback, make feature requests, stuff like that. So, and Carlos said to say kudos to the front end devs in chat. So we will definitely let them know. I think a few of them might be in chat already. So, but yeah, no, I think the UI is really shaping up here. It's looking really, really good. So, yeah, thank you for that. That's a great compliment. We really appreciate that. So a lot of work goes into this UI, and containers are complicated. You know, it's not easy to get all of this stuff right across, you know, whatever 8 million containers are available out in the world right now. So
yeah, and I compared, you know, the FAT container with the Slim container, but we can also do something else here because we can be connected to multiple registries. So we have our ECR connected registry here, and we have our Jammy tag, but I also have this app published in my own Docker Hub. So if we just bring this up and we pick up the Jammy app from my Docker Hub, we can do comparisons across registries. Now, this is useful because you can also copy images between registries using this tool as well. And in fact, that's how I put these containers into the ECR registry. I'd actually got them in our Slim DevOps storage, and instead of having to push them from my own machine, I just got, you know, computers somewhere on the internet to do it for me. So, you know, it's very, very handy. So if we look here, we can see modifications in blue and new things in green. So there's clearly some things changed here. So here's my app, which is blue, so has changed. And if I take a look here, we can see the file size is different. And if we look at the contents, we can do diff level things here. So my hello world in my endpoint here has actually changed to hello AWS containers from the couch. So, you can see down to, file level diffing, what the difference between these containers are. But they were also different sizes. And when we go and look at the Docker file, what we can see here is that somebody has accidentally left a developer tool in the Docker file and has inadvertently shipped Nano inside the other container. So, this is a nice way to sort of, go and see what you're doing. Maybe you need to check on something. You've got a skunkworks registry somewhere and you want to compare what's changed and happened between images. You can go and do that.
Yeah. Hey, Martin, I have a question. So I can see how this could be really useful for like forensic analysis or looking at the different layers of a container image and how that's changed. But what do I need to think about or do when I want to do this at scale? Like let's say I have an automated release process. What can I do to automate the minification of container images?
Yeah, I can feel that one. So, because I think it kind of segues with some of the questions that were coming from Carlos, both around signing and SBOMs and the sort of availability of different reports. So we have a design partners program right now that we're working with sort of selected teams and organizations who are trying to scale sort of this approach. Like this is all free for individual developers. So if you want to come use the dev tools, just sign in. You need a GitHub or a GitLab account. It's free. But once you get into the teams use case, like you mentioned, Jeremy, scale is going to happen. So we're working with a couple of people. We do things like, CI integrations where we have sort of a Slim agent that might run with your CI pipeline that can kind of talk back and forth with our system to automate some of these processes. So maybe you come and you set up the initial configuration for optimization for your containers through the SaaS, but then that becomes part of an automated process that runs in CI and hits your test suite, and everything's kind of running well. We actually have worked with companies. We have a case study with a company called PaymentWorks, who's a enterprise payments provider, and they're actually using us every time they run a build with ECR. We're actually going to publish this on the AWS blog pretty soon. That we auto-generate for them a set of artifacts, including a Docker Compose file that's auto-generated for them that they actually push back into their source code repository so they can see changes over time. Carlos asked a little bit about, could you have the diff reports? I think we're looking at that right now, whether we could do a JSON file version of the diff reports that would be a similar artifact. So yeah, that's kind of the way we see it going. This tooling is like, this developer tooling is important for the individual developers who are working on containers. Then the CI/CD connections and the sort of the connections to the cloud platforms and the registries are where we get to that kind of scale. We are looking at SBOMs as part of sort of this package that would be generated as part of these artifacts, and I think we'll have some improvements on that coming up, because obviously it's important to generate an SBOM both for the original container and then for the slimmed container, all in one sort of automated process, and store those both. On the signing front, and I think I know where Carlos, I'm 99% sure I know where Carlos works. So yeah, we're looking at it. I think, Kyle's been looking at SigStore for Docker Slim because it's important to sign your images as well. And so, you'd want to automatically sign your slimmed images. So I think if there's, collaboration opportunities there, or, I know that we've been looking at SigStore and those types of signing facilities. We know that'll be important. And then I know the OCI is kind of working on like where that stuff would live and how that would integrate with registries. So we want to be part of that whole thing and make sure people are signing containers. We'll probably reflect that in the UI of the platform at some point to say, is this signed, is it not signed? But I think we have some more work to do there. So Slim signing, yeah.
I think
build Slim, sign, ship, right? That's
I think it's important to understand that signing an image as you're getting ready to produce, allow it to be consumed at that point. SBOM is just right there, is as important as the signature, and the signature on the SBOM itself. So I mean, the whole thing is starting to materialize as table stakes for how a consumable image can now be seen. And then also with respect to SBOMs, there's a whole world out there of different SBOM
Mhm.
types, right? And creators. So I'm not sure which standard is going to materialize, SPDX, Cyclone DX, but it seems like, at a minimum, if I'm going to produce an image and I want it to be consumable in the open source world or whatever, I better have an SBOM, and I better have a signature for that SBOM and a signature for that image as well.
Mhm.
And it better be
Yep.
discoverable very easily, right? So
Yeah. And I think at Slim, we just want to really integrate with that whole, like you said, a lot of great things are happening. We've been using we have Gripe in here, and we've been using Sift a ton on our streams over at twitch.tv/SlimDevOps. We play around with those because it's important to do this as you're going through to understand. And, we've been generating tons and tons of SBOMs and seeing what that looks like. But I agree there's some maturity that needs to come into this system. And I think we want to be sort of a platform that helps facilitate that, but also doing this optimization, this sort of production readiness, because we feel that's kind of where our special sauce is. So
yeah. And earlier on, Pete mentioned that you can access all of these tools as an individual developer. Just connect through either with Atlassian, GitHub, or GitLab accounts. We also have the Docker desktop extension that we mentioned earlier, which I don't have on the right screen. So let's fix that. And again, this is free to use. It's available in the extensions marketplace in Docker. And if I take a look here, you'll see that locally I have a bunch of these same containers locally. And if I, pick up the Jammy container, I can explore it in just the same way we've been doing on the SaaS platform. So you'll have access to much of the same tooling. Now, this is a subset of the capabilities currently that we have in the SaaS platform, but there's a whole lot of value in here. So if you are using Docker Desktop, you'll probably want to take a look at this. You can even do the comparisons. So if I choose the Slim version here and then hit compare, I can now do a comparison locally. So this saves you having to push stuff up into a registry somewhere to go and inspect it and take a look at it. All of this stuff is available here, just as we've just shown you.
And yeah, and it's also important to note you can actually do this same diff between things that are in the cloud. Let's say you have something up on ECR, which is like the latest version that your team pushed, but you've been doing some local development. You kind of forgot how far away you've gotten from whatever container of record is up there. You can actually do a diff locally here versus what's up in the cloud and just see what that delta looks like. So yeah, powerful tool. People have been really getting into this Docker desktop extension. So if you just click on that extensions tab, add extensions,
manage extensions or the marketplace to go and find. And we're in here. You won't see it now because I have it installed, of course.
Yeah, I've used it. It's really slick. It integrates really nicely with Docker or Docker Desktop. Speaking of which, there are other runtimes like Containerd, Podman. Does Docker Slim and Slim.ai work with those yet?
Short
Work
answer,
in progress.
No. Short answer, no. Long answer, no. Yeah, so it requires the Docker daemon. Docker Slim requires the Docker daemon to run. So it works with any OCI compliant image. So if you're building images with Podman and you happen to have Docker in your environment, then you can certainly run Docker Slim and do that. You can use the SaaS to slim any image that's OCI compliant. But there are not currently, you couldn't run Docker Slim in Kubernetes with Containerd or something like that. We've had asked for it. I think, we've added a couple sort of like Kubernetes experts like Ivan Velechko to the team recently, and I think they're kind of noodling on how far we would go with that. So it's a common question, common request.
But like you said, I mean, it is generating OCI compliant images, which can be consumed by Containerd and runtimes. Right.
So certainly nothing preventing you. I mean, we just see ourselves as being kind of upstream from Kubernetes a bit, with, developers and developer desktop and stuff like that. We see a lot of this happening before it sort of gets into Kubernetes. And maybe we'll change our mind on that, further down if we get enough questions like that. So.
So do
Now,
you see the tool maybe being used to create so-called golden, or golden base images or whatever? Would an enterprise maybe use this tool to start on the right track of building these very small base images that allow their developers in the wild west take off with them?
Yeah, I think for some, for some enterprises that are huge, that have 30-person developer experience teams that only work on images, like there are other tools that we have that they might use internally. There's this collections tab that we probably shouldn't get into because we're still kind of building it out, but that's a way of sort of making sure your developers are using the right images, and that you can kind of audit them over time, and that people aren't just going up and grabbing Python latest off Docker Hub and slapping your application on top of it and shipping it. Um, I'm not entirely sure that, how much optimization is needed for people who are like really, really low level container experts. And I think that's an open question for us, which is, okay, I know how to use Distroless. I know how to use, build containers from scratch. Do I really need Docker Slim to go slim those images? It does do things, it can still remove vulnerabilities in that. But I think the impact is a little more limited in those types of use cases. So.
yeah.
So I would point out something that you just said with respect to being able to tell what developers are using, what images are being used, and that type of thing. That actually is a point of audit, to be able to tell what images are being used, so that you can understand where they're at in your enterprise. And not only that, but also, I mean, there are enterprises out there that are struggling with, how do I prevent or filter or at least monitor all these images coming from outside of my boundaries into.
Yeah, we see that a lot too. Actually, that's been a very common question for us. Like people, there's this sort of confluence happening in the marketplace right now, right? Where if you're consuming third-party containers into your infrastructure and those containers have vulnerabilities or attack surface that you actually don't have control over, right? What's your recourse? You push back on the container producer and you say, hey, remove these vulnerabilities. And they come back and they say, hey, we did, or we patched that, or that's a false positive from that scanner, and it just creates this thrash because it's the security people on one side talking to the customer service agents on the other side, who then have to talk to the security people who then have to respond. And so, I think there is sort of this sort of publishers clearinghouse thing that needs to happen, that we might be able to help. So I think that's the point. Yeah.
We have about 10 minutes left, and there are a lot of messages in the chat. Looks like Big Pod has been answering a lot of them. Thank you for that. But do we want to surface any of those here? Do we want to try to answer them live?
By all means, if there's any that you want to bring up, you're more than welcome to do so. I think at the beginning, Jimmy was asking about Distroless. So whilst you go hunting for any questions you want us to address, I thought we'd take a look at Distroless, which was the smallest container, composed in a traditional way. And here it is. So let's go and take a look at the vulnerability analysis, because, a smaller container, fewer packages, fewer files, it should have a decent security posture. But this has 29 vulnerabilities, even though this container is half the size of the one that we composed using Ubuntu. And so this was, interesting and part of a study I did recently. And what's happening here is, again, using our tools, I actually went poking around inside the Distroless images to understand, well, what are they? And ultimately, they're based on Debian 11, or at least this one that I'm using here is. And the issue is this: the Linux vendors, the commercially backed Linux vendors, have SLAs, and they will ensure that the high and critical vulnerabilities are patched within a particular time period. And for RHEL and Canonical, I believe that's 24 hours in most cases, whereas the community supported distribution simply can't maintain that kind of commitment to security. So yes, whilst Distroless will help you make smaller containers by default, it doesn't necessarily mean that they're going to be more secure by default. And, another question that we often get asked is, oh, well, I don't need to do slimming or minification because I'm using Distroless, I'm using Alpine, I'm a build pack expert, and I have this curated artisanal container. Well, there's nothing stopping me hitting the optimize button anyway. So, you know, here we are, we've got our Distroless container. We're going to publish this back into ECR again, just as we did last time. We'll rattle through these. We're going to say it's a server. We don't need it to include any additional files. I don't have a Docker Compose. We've got some additional environment variables in this one, primarily because it is Distroless and it moves things around a little bit. So let's let this do its thing. And just like last time, we can see down here, his Docker Slim doing its thing. Oh, have I bitten off more than I can chew?
I was going to say, our demos never go this smoothly.
I saw an error.
We've been pretty good up until now. Yeah. Carlos asked before if we have a Twitch stream, and if you want this kind of hilarity that, you know, we're usually breaking things on the Twitch stream. So stop by. It's twitch.tv/slimdevops. But oh, it looks like something happened there.
There we go. We're fine. It's all fine. So we started with the Distroless container that was 71 megabytes. And we have a minified container that's 21 megabytes. So a 3.5 times reduction. So if we go back to our view of things here, what we'll learn is that actually
I think you actually saved that one up into the Slim clouds.
Did I?
Kind of somewhere else for you. Yeah.
Well,
sorry.
How big was it? It was
21.
It was 20, yeah, but and these sizes won't match because these are the compressed sizes. But what you will have found is it would have been about 11.5 megabytes, almost the same size as this one here. And so you may start with Distroless or Alpine, but you can still minify those. And you can, you know, if you're comparing a Distroless base image with an Ubuntu base image, you can sort of have your cake and eat it too. You can generate your app inside an Ubuntu container and have the sort of same security profile you might get from Alpine and the same size that you would get from Distroless or Alpine, and then optimize it. And you can go one step further and get containers that are smaller still. I have built this app in Alpine. I think the default container was like 54 megabytes or something, and the version that's been optimized again came out at about 20 something megabytes. They were all within a megabyte or so, you know, the same size.
Interesting.
And then, of course, there's this great big chonker down the bottom here.
We could try optimizing that one. I wonder, it would probably do the same thing, I would assume.
Well, let's find out.
Yeah.
Well, I guess my assumption would be if I'm building something, you know, I would never get to that big, you called it chunker at the bottom there with Python. Because I would probably, I mean, even though I probably needed Python to build, I would probably build it in a multi-stage build, right? And so by the time I got a candidate image to go through Docker Slim, I should have already multi-staged that into a small image to start with, right?
Yeah. And we have slimmed multi-stage builds before, and they do. It's similar to the Distroless example where it's like, you know, we might carve out 6 megabytes, 8 megabytes here or there. I think in those cases, you know, the impact is a little bit less on the, you know, just pure kind of, you know, removal side. But, you know, I think with this, you get the comfort knowing that, you know, you're removing certain packages and removing certain, you know, shells and package managers and those kinds of things. And you get that diff. So
Carlos asks an interesting question here. So he says, are there problems with vendors and their support statement when one of their images gets modified by being slimmed and customers lose support?
That is a good question that I don't know that I have a great example that I don't have a great answer for. So I might have to circle back with Carlos on that and get an answer from our team. I mean,
we haven't
run into that yet.
The chances are you're taking a base image from one of those vendors and adding stuff to it anyway. So at which point you've changed it, and they won't necessarily support that if you've pulled in things from outside of the sort of supported registries and archives. Now we are speaking to some of these organizations to address that.
So with vulnerabilities, I want to ask real quickly, are you going to add to it? So like some type of scoring method, so like CVSS, or are you going to maybe also look at, you know, up and coming, you know, VEX that's out there.
Yeah.
Giving folks more intelligence around the vulnerabilities, not just the vulnerabilities.
Yeah, we've talked about, we've been looking at Vex. We've been talking about sort of like a Slim score sort of for that use case of selecting a base image, because there's a trade-off, right? There's sort of like developer friendliness in an image versus, sort of production readiness. And I think you need actually two scores, right? Which is one's like, is this really ready for production? Have we taken all of the attack surface out of it that we can? Does it have a reasonable vulnerability profile with no critical or high vulnerabilities inside of it, or have those been addressed? But you wouldn't necessarily want to have a great score for something that you're just starting development on, if you want to start with the Ubuntu base image or something like that. So we've been playing around with that idea. We might have something on that around KubeCon time, but we'll have to come back and demo that for you guys if we come up with something good there. So I think it's a good idea. But
so I think we're out of time for today's session. I want to thank our guests, Peter and Martin from Slim.ai. This has been a great and very interactive session. Definitely appreciate it. And if you're interested, go to Slim.ai and give it a spin. It's really
Absolutely.
fun. And we've pasted links to additional resources into the chat. Hopefully you've managed to capture those. If not, this video is going to be uploaded to our YouTube channel, Containers from the Couch, or cftc.info, and you can watch a replay of it there. So thanks again, and we'll see you tomorrow for another episode.
Yeah, thanks everybody for coming and join us on our Discord. Love to see you.
Well, that was a really good session. I mean,